So we're going to talk about, actually this is what's some of my favorite stuff. So, and this is has super, if we get this down, you will get, you'll definitely get one of the 6 free response questions right. Okay? So anytime we can get one of the free response questions right, that's awesome. So, we've got left and right area approximations is what we're going to talk about today. I do not use the book at all for this because I don't like the way the book does it compared to how we have to apply it on the AP test. Okay? No, there's homework. I made a worksheet for you, okay? So, this is not very difficult. If you can multiply the area of a rectangle and add up some numbers, you're going to be good today, okay? So, today is a really, really good day. RRAM and LRAM will make more sense here in just a few minutes, okay? So, my question is, do we know how to find the area of that object? How do you find the area of that object? Sorry. That went too fast. I meant to get my... So what do we... That's a rectangle, isn't it? So what do we have to multiply together for a rectangle? The base times the height. Okay. So area is base times height, or length times width, right? What about the area of that object right there? What's the area of that one? It's 1/2 base times height. Okay. What about that object? What if I didn't know the formula? Because I know that there's a regular polygon formula, but I can't remember it. Could I divide it up? What about that one? Do you remember the area of that one? Or that one? Or that one? Alright, but we do know the area of a triangle, don't we? Couldn't I divide them into triangles and add them up? Okay. So that's the idea is we know areas of rectangles, we know areas of triangles. If I can break an object up, I can add those areas together. Or actually, I figure out one and multiply it by 5, right? Alright, so... Here's the next thing. Can you find the area of that object?
Oh, you can divide it into rectangles, can't you?
Okay. It's got a curve on the top, though. Alright, so here's why we need calculus. Because we need to be able to find the area of that object. Because how many objects do we have in our life that aren't rectangles, right? Think about all the parts inside of a car. No, hardly any of those are rectangles, okay? And once we go 3-dimensional, we've got to be able to find the area and volume of things, okay? So that's calculus. So if I put it on here, okay, so I'm putting it on a coordinate plane, and I break it into rectangles, I can approximate the area of it. You watching, Jordan?
Yeah.
You were right. So I can, but I'm missing some parts, right? I'm a little bit over here, and I'm a little bit under there. So could I make the rectangles smaller? Oh, I can make them go over the top. Okay, so that's another way I could approximate it. I could cut them in half. And I'm getting better, right? So the more rectangles I add in there, the better my approximation is, okay? So the width of the rectangle is really the approximation. Eventually that width, in a couple of days, is going to become our dx, okay? So that's what, the dx has a purpose, that's the purpose right there, okay? So, what we're going to talk about today is called the left rectangular approximation and the right rectangular approximation. Do you have to fill that in? Yeah. Okay, so fill that in. Okay, so the M stands, so it's left rectangular approximation. The M stands for method, okay? We abbreviate them LRAM and RRAM. What we really want to do is we have to have a method to draw the rectangles. So if we're going to come from the left, we start over here. So we start from the left side, and I draw a rectangle. So let's say I'm going to split this into, there's 1, 2, 3, 4, 5, 6 dots there, right? It's good to practice drawing, okay, on this, because you want to be able to draw them correctly, okay? So you got to practice with me. So my first height is at 0, and it goes over to this dot. My next height, and it's going to make more sense when you can actually kind of see it and it's not right on there. I go up to the rectangle and I draw a height down. From here, I go up to, sorry, not the rectangle, the curve, and I draw a height over. I go up to the curve, draw a height over. Does that make sense now? Oh, yeah. I go from where the X value is, I hit the curve, and I draw the rectangle over. I go all the way up to the curve, and I draw the rectangle over. So that's coming from the left. So coming from the left means I start with 0. Okay? No, they do not have to be perfect, but you need to be able to understand the sketch and how to sketch it. Okay? That's all I'm asking, is that you understand how to sketch. Okay. Coming at it from the right means I'm going to start with the rightmost value. Whatever that X value is, I'm going to start with the right. So I'm going to go here, I'm going to go all the way to the curve, and I'm going to draw my rectangle. Okay. I'm going to come here, I'm going to go all the way to the curve, and I'm going to draw my rectangle. Notice this one's kind of going over the top, right? I'm going to come here, go all the way to the go all the way to the curve, draw my rectangle down. Come here, go all the way to the curve, draw my rectangle. And then here. And do you notice how one of them is all under and one of them's all over? Yeah. So I'm not getting a great estimate, but I'm at least starting that understanding of the estimating process. We're going to keep making it better and better. Okay, but this is the most basic one we can do. Okay, so you ready for the next part? Everybody got drawn? Not yet? Okay. So notice that was the exact same picture, right? And we drew it 2 different ways. So we can do this with, we may only use a couple of functions here. So we're going to approximate the area under the curve using n subintervals on the given interval with a left rectangular approximation. So it says that we're coming from the left. It says that we're supposed to use this many subintervals. So I'm supposed to break it into 5. It says that I'm on the interval 0 to 5. Okay, that's important because if I was on the interval like 0 to 10, that would mean that the base of my rectangle would be 2. Okay, this is the function we're looking at because we're going to have to calculate some height values here. Okay.
Good morning, teachers and students. Mr. Rutkoff's class. Are you welcome to attend the library? Mr. Rutkoff's class, please proceed to the library. Thank you.
All right, let's start by drawing our rectangles. It says we got to come from the left, so I'm drawing this first rectangle is basically flat. The second one means Mr. Rutkoff didn't make it to work, huh? All right. So all I'm doing is I'm drawing my rectangles coming from the left. So making my height, I'm drawing from the left. Making my height, drawing from the left. All right. Now what we're going to do is we're going to calculate the area of each one of those rectangles and add them up. And that's going to be our estimate for the area under that curve. This is a left approximation, so I would probably label it LRAM. Okay, for left rectangular approximation method. All right, so let's looking at this first rectangle. What is the base length on each one of these rectangles? 0. 1, right? Each one of those has a base length of 1. Okay. I'm going to use a different color because I want to talk about the heights. So this first rectangle, its x value is 0, isn't it? I know the base is 1. Okay, now I got to calculate the height of that rectangle. So when I calculate the height, I can put it into that function. I'm not going to try to read it off the side here. Okay, I'm always going to calculate using the function. So when I put 0 into the function, what do I get? 0. Good. All right, my base is still a 1. All right, but this time I'm putting a 1, an x value of 1 for the height of the rectangle. So what's 1 squared? Good. My base length is still 1. This time what number are we putting in to calculate? 2. What's 2 squared? 4. Okay. I'm putting in a 3. Okay, and so that took care of, I've done this rectangle, I've done this rectangle, I've done this rectangle, now I'm doing this rectangle. Okay, because I only had 5 rectangles there, right? Alright, so my base length is still 1. This time I'm putting in a 3 for my height. So when I put the 3 in, what do I get? 9. Good. And now I'm going to do this final rectangle here. So what's my height that I'm going to put in? Base is still 4. The height, or the x value I'm going to put in is 4. 4 squared is 16. Do I really need all those 1s? No, it's not always going to be 1. A lot of the ones I'm going to show you are 1 today, but it could be a 2. It could be a half. Okay? Probably more likely to be a half than 2. Alright, so let's see if we multiply that out. I see this one's going to go away, and then I got 1 plus 4 plus 9 plus 16, and what is my LRAM? 30 is the approximation for the area under that curve. You can just write, yeah, you can write LRAM equals 30. Okay? As long as you got the equals lined up, you're fine. Alright, pretty easy, right? Let's try it again. We're going to keep going on the left. So I'm still doing a left. What is my n value? How many rectangles am I going to break it into this time? 4. Okay, I'm at 0 to 4, and luckily my picture is 0 to 4. Okay, this one's a little bit more exciting. I moved up the point there, so we got a little bit different values. All right, so I'm going to start from the left and draw my 4 rectangles. So everybody draw your 4 rectangles. Practice that part. Okay. What are all of the base lengths? They're all still 1. Okay, so I'm going to set that up. I know I have a total of 4 rectangles. So as soon as I do that, that way if I set that up, I know when I run out of rectangles, I don't have to keep putting in heights. Okay? Alright, so my first height is going to be, or my first x value is going to be 0. So when I put 0 into this function right here, what do I get out of it? 3, because it's 0 squared plus 3 is 3. All right, what number am I putting in next? 1. What's 1 squared? Plus 3? 4. All right, what number am I putting in next? 2. 2 squared? Plus 3? Good. This time what's my last number that I'm going to put in? 3. 3 squared is? 9 plus 3 is 12. So again, I'm not going to worry about writing that out. I need to basically add 3 plus 4 plus 7 plus 12, and what do we get? 26, I think. All right, we good? I told you it was pretty easy today. All right, let's look at the next one. So example 3, what does it say about our approximation? We're now coming at it from the right. Notice, it's the exact same problem as example 1. Okay, but it's going to have a very different answer. Okay, because of the direction we're approximating it. So let's draw our rectangles. I know I'm coming at it from the right side. So I'm doing this first rectangle with a height of 5, or height at 5. Second rectangle, height at 4. I'm not doing a very good job. Half the battle is making sure, oh boy, that one's really bad. There we go. Okay, so how many rectangles did I draw? 5. What are all their base lengths in between? They're all 1 again. I'm going to label it as RRAM, okay? And I'm going to set it up that I have 5 of these rectangles. So that I know once I've got 5 x or height values filled in, I'm done. Alright, the way I set this up is weird, okay? We typically don't work from the right to the left. Okay, but that's the way I do this one because it's a RRAM, all right? You have to work this way to get the problem solved. So what I'm going to start with is I'm going to start with the rightmost height. So what's the rightmost x value? 5. All right. So if I put 5 into this function, what do I get? And because I started from the right, my brain is saying write it here. Okay? Is that the way every teacher is going to do it? Absolutely not. Okay? That's just the way that I'm showing you how I think about it. Okay? I don't think Mr. Lepis does it that way. Okay? All right. I'm starting from, what's my next value that we're going to put in? 4. So what's 4 squared? 16. Perfect. So, and I know that I'm going to, so I'm kind of matching what the picture looks like. That's how my brain is working. Okay? All right. What's going to be the next number I put in? 3. 3 squared? 9. Good. All right. What's the next number I'm putting in? 2. What's 2 squared? 4. All right. What's the next number I'm putting in? 1. 1 squared is? 1. Notice I didn't use the 0, right? Because we've already got the height. We've already got the heights of all 5 rectangles. So from the RRAM you leave out the 0. Notice from the LRAM we left out the 5. Okay, so that's kind of the big difference. All right, we got to add those up. So you got 1 plus 4 plus 9 plus 16 plus 25. We get 55. Very, very different than the 30 we got before, right? So this one, notice it was kind of over the top. The other one was underneath. So likely the actual answer is between 30 and 55. Those are just estimates. Okay. All right, let's try another one. A little bit different this time. Notice I changed the curve, made it go upside down. Okay. So completely different curve than we've worked with at this point. I'm going to draw my rectangles. I'm coming at it from the right. So this first rectangle, the height is 0, isn't it? Yeah. Then the second one, we hit the curve, draw the rectangle, hit the curve, draw the rectangle, hit the curve, draw the rectangle. All right, we're supposed to be doing an RRAM. How many rectangles did I have this time? 4. What is the base length on each one of them? 1. Okay, so 1, I'm going to draw a spot for a height, writing all my base lengths in there. All right, since we're coming at it from the right, what x value am I going to put in first? 4. Good, so we're putting a 4 into this function right here. What is 4 squared? But it's really negative 16 plus 16 is... Look at your picture. Does that make sense? Yeah, it matches what we have in the picture. Okay? I did write it from the right, but this time it's a decreasing function. All the others were increasing. See how I changed it on you? Okay, and there is a difference there. Okay? All right. Oh, I'm sorry. You're right. I should put it over here. That's what David was having an issue with. Okay. I showed you the opposite way of what I did it last time. All right, now we're putting in a 3. Okay. What's 3 squared? So negative 9 plus 16 is? 7. All right. What are we putting in next? 2. Okay. 2 squared. So negative 4 plus 16 is? 12. Good. And then I'm putting in a 1. 1 squared is? Negative 1 plus 16 is? 15. Ran out of rectangles, right? Do you see how writing that out helps you? Because if you didn't write that out, you might be tempted to put that 0 in, and then you've got too many rectangles. All right, add them up. What do we get? Should be 34 on that one. Okay. All right. We're going to do one more here. Okay. It looks like I'm going to switch this one up a little bit. Okay. Oh, you don't have that one? Oh, you only have that. Okay, awesome. All right, apparently I didn't put example 5 in there. All right, let's look at we'll look at it with example 4 because it's the same problem, isn't it? Okay, so what words did I add in there that was extra? Okay, so we can tell if it's an over and under. You have that picture there, right? Okay, so do you notice how there's two different types of functions? Either we have a strictly increasing or a strictly decreasing function. Okay? If we are strictly increasing, all right, and we are coming at it from the left side, does it look like an overestimate or an underestimate? Underestimate. There's something under, right? There's gaps underneath. All right, but if I'm strictly increasing and I draw my rectangles from the right, is it over or under? Over. Write that underneath. Okay, so you have an example of each. Okay? All right. Then let's look at the strictly decreasing. So if I'm drawing my rectangles from the left and I'm strictly decreasing, is it over or under? Over. Okay. And then if I'm coming at it from the right and I'm strictly decreasing, is it over or under? Do you see why it's important to be able to draw the pictures? You can draw the picture. You can always draw your rectangles and decide if it's an over or under from the picture. These words here, this strictly, shows up in for your response questions. Okay? And it'll be just a word in there and you'll miss it, right? You really got to look for that word strictly. It's a very important word, okay? Because it really helps you tell. If you see that word, you know they're going to ask you about an overestimate or an underestimate. All right, let's go back in and look at what we did. Okay, so let's go back to example 1. Let's decide over or under, okay? So looking at example 1, was it an overestimate or an underestimate? Under. Go ahead and write that in there. Okay? That's all the homework that's going to ask you about it. All right, what about example 2, over or under? It was also an underestimate. Okay, what about example 3? Example 3 was an overestimate. All right. What about example 4? Example 4. I noticed it was the right, but it was an underestimate. So it doesn't matter. You don't want to just memorize one direction is always under, over, because it could be both. Okay, it depends on if it's increasing or decreasing. All right. I know you don't have this one, but I want to talk about something else with it before I let you loose on the homework. Okay. Let's pretend instead of it being an n equals 4, it's an n equals 8. So that means I now need to add in extra marks, right? So again, I would still do the same thing. I would come at it from the right side, okay? And then I go up there, come at it from the right side. I'm just going to add more rectangles in there, okay? I'm not going to draw them all. What's my distance in between here, though, now? It'd be 1/2. So my base length would be 1/2 on all of them. Or divide by 2. So when I have a bunch of 1/2s like that, I don't know, whatever the heights are, I don't know, 5, 4, 3, whatever they are. Do I really have to multiply 1/2 times each one of those? Couldn't I factor it out and add the numbers? Yeah, that's what you're gonna, that's the shortcut to be able to, so don't freak out when you see the fraction, okay? So you can factor it out and just add all the heights together, okay? So just watch for that. I know we didn't do any but there will be one, I think, that's a 1/2, okay, on the homework, or 2 that are a 1/2 on the homework. All right, look in haiku. Okay, the homework is posted there, but I am going to give you a paper version of the worksheet as well, okay? Because I want you to be able to draw your rectangles. Okay, I'm going to give you 2 papers, okay? So you can, but you still have to glue it into your, you can do your homework right on here, but you have to glue it into your notebook, right? Because there isn't a whole lot of work you have to show today.
Hey, David, where's your card? What? Because I'm trying to show Alexis how good I am in Spanish. You're not. Have you beat me yet? I beat you like 3 in Spanish? Yeah, in Spanish.
Okay, I'm going to give you 2 things, okay? Because I did all the copying today. I'm going to show you. Get haiku going. Okay, so look at the worksheets I just gave you. What I'm going to do each day is I will post in haiku which one you are doing, okay? If you notice, the one says, the first one I passed out on the top says AP Calculus Rectangular Approximation. That's tonight. worksheet, I just changed the words at the top, isn't it? Yeah, because I'm going to teach you 2 more approximations tomorrow. Okay? What's wrong? Yeah, another one of those. Did I not count? All right. And then on the next day, so you can even start. You can get ahead. All right. This one is going to be the one for Thursday. This is the one that's smaller. Okay. The new thing we're going to learn on Thursday is we're going to learn how to do tables that are on the back. Okay. But the first 4 are what we did today. So you can get a jump and get ahead. Okay. Or at least some of them are what we did today. You can do part A and part B, right? Left and right. So if you wanted to get through the left and the right on there as well, you could. All right. So I'm giving it all to you now so that you guys are responsible for holding on to it, not me. Okay. So since I did the photocopying. Yeah. All right. So you guys have some time to get started on that. Okay. I wonder if it's the bulb in that projector.
Oh, I smell it.
Yeah, because I could smell it too. Huh? Oh, that's what it is. It's the heater. And you know, notice how they don't turn the heat on until 7:30. And we're here at 6:30, right? All right. Well, some of us are. Okay. That one doesn't look done, right? Okay. Okay, so 71's done. 74 is done. And that one's not done yet, right? 76 done?
No.
Not quite. That one? Divide each one of them out by square root of x. So go x squared over x squared of x plus x. We did one like it in the notes yesterday. So, and then make it a 1/2 exponent, right? This one, these two subtract your exponents, right? You're going to get fractions, okay? And then this one, just make it negative, bring it upstairs. That makes sense? Okay. Always try to simplify first.